Well, welcome to 9.3. In 9.3, we're getting the polar form of a complex number, or we're taking complex numbers and making sure that we understand them. And so there's some problems right in the very beginning that I thought we could do all together, and that is number 12, 16, and 20. So as I look at number 12, let me write 12 here for just a minute. We have the complex number negative 1 plus I, and they're asking us to plot each one in the complex plane. So what you've read or seen in the PowerPoint is that this is the real axis and this is the imaginary. So the real axis is the x-axis and the imaginary axis is the y-axis. And so as we're asked to do negative 1 plus I, well, we're going to move negative 1 in the real axis and I in the y-axis, and our point would be right there in the imaginary plane. And so what they would like us to do is get the polar form for that. And so the polar form is, for a complex number, they're going to call it z, is r cosine theta plus I sine theta. There's also a shorthand notation that you might remember from your last class, r cis theta, where it's understood to be cosine I sine. R is going to be found the exact same way that we did before, x squared plus y squared. So in our case, we have the square root of negative 1 squared, and the y is whatever's in front of that I, and so that's a 1 squared. And so our r is simply the square root of 2 if we add those guys up. So now we know our point so far for number 12. We know the r out front is root 2. We know it's cosine of an angle plus I sine of the same angle. Now they're asking for that angle in degrees. Well, how do we get that angle? We can use the tangent. We know tangent theta is y over x. So in our case, 1 over negative 1. So tan theta is equal to negative 1. And we know that 1 is associated with a 45-degree angle. We also know from the picture that we did first, it was very wise that they asked us to put the dot in there, that it's going to be a second quadrant angle. Well, a second quadrant angle that has a 45-degree reference angle is 180 minus 45, or 135 degrees. So our answer is this. Our answer is the square root of 2 CIS 135 for number 12. That's what we're doing in all of these. So I'm going to scan up for just a minute so that we can look at number 16 together. Number 16 is just a single number, negative 2, but it exists in the complex plane. And so where is it? Well, it's got a negative 2 as its real part and absolutely no imaginary part. So its x-coordinate is negative 2, its y-coordinate is 0. So we're almost done. You can see that the r is flat out 2. There's a distance. Let me change the color here. There's a distance of 2 from here to here. And that's all r is, the distance from the origin to the center. So we don't have to go through the formula if we understand it. So r is 2. And then the angle, well, we already know the angle as well. The angle is this angle right here, which is 180 degrees. And so what is our result? Our result is our complex number written in polar form is 2 CIS of 180 degrees. Again, what is that? That's 2 cosine of 180 plus I sine of 180. Okay, and it's 2 times that whole thing if we write it out like that. The last one that I wanted you to be aware of is one like number 20. So number 20 has 2 plus the square root of 3i. Well, we know how to plot that. That's over 2 in the x direction, root 3 in the complex direction. And so where are we at? Square root of 3 is less than the square root of 2, so it's right about here. Right? Up here I might have misspoke. We went over negative 1 for number 12 in the x direction and 1 in the y direction. I might have said I now that I'm reflecting on that, but it should have been a 1. So how do we get our r? No problem. It's the square root of 2 squared plus the square root of 3 squared. So r is equal to the square root of 4 plus 3. So r is equal to root 7. So now we know it's root 7 CIS. And now we just need to come up with the angle. And again, they want it in degrees. And so how do we do that? Well, we let our tangent theta be y over x. Now, root 3 over 2 is a known output, but not for tangent. It's for sine and cosine. So I think this is going to be one that we don't know. So we're going to have to turn to our calculator and take tan inverse. So let's go grab tan inverse of, and I'll plug into my calculator the square root of 3. Square root of 3 divided by 2. And it's going to tell me this. It's going to tell me theta is 40.89. It keeps going. It's 8933, but 40.89 degrees. I did make sure that my calculator was in degree mode because that's what they're asking for in these ones, is for the answer to be in degrees. Now, this is a first quadrant angle, and if you remember, tan inverse can give us a first quadrant or a fourth quadrant. Well, we happen to be in the first quadrant, so we're going to take our 40.89. Notice that if these were both negative, we'd still, if the 2 and the root 3 were both negative, we would still end up with the tan theta equaling a positive, and we'd have to add the 40.89 to the 180. But we didn't have to do that because we're in the first quadrant. And I just wanted you to be aware that some are calculator problems. So let this be the guide along with the books for those initial problems.